Today we're going to talk about indices. Let's say that you have 2 times 2. We all know that 2 times 2 is equal to 4. And now 2 times 2 times 2 is equal to 8. This part is 4 and this part is 2, so it's 4 times 2. Let's say that now we have 2 times 2 times 2 times 2 100 times. It would be really difficult to write it. So we use a system called indices. What we do is write 2 to the power of 100. And here we're going to write 2 to the power of 3 because there are 1, 2, 3 2's. And here 2 to the power of 1, 2. So we can write that 2 to the power of 2 is equal to 4 and 2 to the power of 3 is equal to 8. One more thing, we all know that 2 is equal to 2. So 2 to the power of 1 also equals to 2. Now you have 2 to the power of 3 multiplied by 2 to the power of 2. 2 to the power of 3 is 8. We just calculated that. And 2 to the power of 2 is 4. So it makes 8 times 4, which equals to 32. But 8, if we can write that in terms of 2, it would be 2 times 2 times 2. And 4 would be 2 times 2. So it's going to be 1, 2, 3, 4, 5. 2 to the power of 5, which means that 2 to the power of 5 is equal to 32. Here we can write 2 to the power of 5. What we can see is that this power here and this power here has been added to make 5. So we can write that 2 to the power of 3 plus 2. From that, we can say that there is a multiplication law. Let's say you have a certain number a to the power of m times a to the power of n, where a can be any number and m and n also, it's going to be a m plus n. This is our first law of indices. Now I give you 8 divided by 4. We all know that 8 divided by 4 is 2. But let's break 8 and 4 in terms of 2. That would make 2 times 2 times 2, just like here. And 4, 2 times 2. And we're going to do our division. 2 divided by 2, 2 divided by 2, which remains 2 to the power of 1. We could have also 8 and 4 as 2 to the power of 3 divided by 2 to the power of 2, which makes, as we can see, 2 to the power of 1. And we can see that those two powers have been subtracted from each other, so it makes 2 to the power of 3 minus 3. 2 to the power of 3 minus 2. From that, we can write something called the division law. Let's say you have a certain number a to the power of n divided by the same number a to the power of n, which would make us a to the power of m minus n. That gives us our second law. Now, let's say you have 2 times 2 to the power of 2. 2 times 2 makes 4, alright? And we put the power outside, so it makes 4 times 4. 4 square, 4 times 4, which makes 16. We could have written 2 times 2, 2 to the power of 1, 2. And this to a power of 2. But here, it's 2 to the power of 2 times 2 to the power of 2. And from our multiplication law, we know that 2 plus 2 equals to 4. So it makes us 2 to the power of 4. So we know that this is equal to 2 to the power of 4. What we can see is that those two powers have been multiplied. From that, we can write our power law. Let's say you have a certain number a to the power of m, and this to the power of n, it makes us a to the power of m times n, or a to the power of m n, or if you would prefer, a to the power of n m. This is our third law. If we had 3 to the power of 5 and this to the power of 6, all we would have to do is to multiply those two powers, which makes 3 to the power of 30. One more thing. The zero index. Let's say you have 2 to the power 1 equals to 2, 2 to the power of 2 equals to 4, and 2 to the power of 3 is equal to 8, and so on and so forth. But if we had to go in this direction, the next number we would have to write here would be 2 to the power of 0. And 2 to the power of 0 equals to 1. That's something that you should know, you should learn. Any number to the power of 0 is equal to 1, like here. 3 to the power of 0 equals to 1. 4 to the power of 0 equals to 1. 1000 to the power of 0 equals to 1. This crazy number, what I just invented, well, to the power of 0 is also 1. From that, we can write that a to the power of 0 is equal to 1, as long as a isn't equal to 0. Let's draw a number line. We've done powers of 1, powers of 2, powers of 3, 4, 5, and so on. And we've even done power of 0. But what happens when you go beneath the 0? Like -1, -2. This is where we get negative indices. I'll give you 2 to the power of -1 equals to 2. 1 over 2 to the power of 1. All we have to do to make that power positive again is just take the number and send it to the denominator. The same thing for 2 to the power of minus 3 equals to 1 over 2 to the power of 3, which makes us 1/8. The same thing is true for 5 to the power of minus 2 equals to 1 over 5 square, which makes us 1 over 25. From that, we can write that x, a certain number x to the power of minus n equals to 1 over x to the power of n. The same thing is true if we had x to the power of minus n, it would be the same. We sum it up and it gives us x to the power of n. Now, I have a divided by b, all of that to the power minus 1, which gives us, we just need to sum the minus 1 for a and a minus 1 for b, which makes us a to the power minus 1 divided by b to the power minus 1. As we've just seen here, a negative number, a number with a negative indices equals to 1 over the number with its positive indices. So, a to the power minus 1 is equal to 1. I won't write the 1. It's equal to 1 over a to the power 1. And b, like we have just seen here, is going to go up with a positive power, which makes us b over a. If we had square root of a, we could have written it as, in terms of power, a to the power of half. Because square root just has a little 2 here. We just sum it up under a fraction. The same thing is true for a divided by b. Square root of that, what's our little 2 here? What we just need to do is sum the square root for a and sum another one for b. As we've just seen here, we could write it as a fraction, a power fraction, so a to the power of half and b to the power of half. Let's say we had cube root of a, which is sum the 3 under the fraction, so it makes us 1 over 3, a to the power of 1/3. The same is true for a divided by b, cube root of that, which makes us a 1/3 and b 1/3. That's all for today. I hope you enjoyed it. I'm going to leave a link in the description for all the general formula we used today. And if you have any question, you can ask me in the comment section. See you next time.